This is Basic Proportionality Theorem or Thales Theorem. What does this theorem say? If a line drawn parallel to one side of the triangle to intersect the other two sides in distinct points, the other two sides are divided in same ratio. So what does it mean? A line drawn parallel to one side of the triangle. Now in this we have a triangle. First draw a triangle. So first drawing a triangle. So if a line drawn parallel to one side of the triangle, draw a line parallel to one side of the triangle. So one side of the triangle, let's take this side. So if a line drawn parallel to one side of the triangle that intersects other side in distinct points, one parallel to this side, one line is drawn parallel to this side and it is intersecting other two sides. This side and this side and this side is intersected at two distinct points. This is one point, this is one point. Okay, so then the other two sides are divided into the same ratio. So these two sides, this is one side, this is one side, are divided in same ratio. That means this particular line and this particular line are divided in same ratio. Let's say if this is divided in 2 4 and this should also be divided in 2 4. That means ratio is 1 by 2. 2 by 4, 2 by 4, 2 by 4. This is 2 4. This side's ratio is 2 by 4 and this side ratio is also 2 by 4. Just let's assume it. So what is the ratio? 1 by 2. 1 by 2, 1 by 2. So this is what it's saying. It is saying. So both the sides, the two other sides means these are the two other sides. This is one side, this is one side. Okay, divided in same ratio. They should be divided. They are divided in same ratio. So this has to be proved. Let's name the points. This is A, this is B, this is C, and this is the line intersecting. This is a line DE intersecting parallel to BC. So after giving the naming, so what is this theorem says? If a line, the line DE is intersecting BE at distinct points, then AB and AC are divided in same ratio. That we need to prove. So what we need to prove? AD divided by DB equal to AE or AE divided by EC. Okay, so AD by BD DB equal to AE by AC. That means ratios are same. Ratio of this side and ratio of this side are same. That is what we need to prove. To prove that, the first step is to join BE and CD. So now I have written BE and CD, and also draw one DM, line DM perpendicular to AC and EN perpendicular to AB. Let's draw it. So EN perpendicular to AB is drawn, DM perpendicular to AC is drawn. Now the next step, area of triangle ADE. Area of triangle area of triangle area of triangle, that means area of this triangle, okay, equal to half B into H. For the triangle ADE, B breadth is AD and height is EL, means which is equal to half AD into EL to EL. Now area of triangle ADE can be written as area of ADE also, okay. To just make things easy, we are writing this way. Now it's half AD into EL. Fine. Now similarly we have written the area of this one. Similarly we have to write the area of BDE, BDE, this triangle. Why? Because we need to prove ratio of this side and ratio of this side. So we are taking the triangles related to this side and this side, right? So now we are taking the area of BDE also, which will be 1/2 into dB into EN. dB and EN. dB is the breadth, EN is the height. And similarly we need to take area of DEC also, area of ADE also, which is half AE and DM, and we also take area of DEC, area of DEC, this one, area of DEC and area of ADE, this side, ADE, this side of the triangles, and which is equal to half EC into dm. So now that we have written all of the areas of all of the triangles formed by formed on the sides of AD and BC. Now the next step is we need to prove this triangle. Now we need to write this triangle by this triangle. That means ADE by BDE, because both are formed on a single breadth, single line, single side. So this is the next step. So area of ADE divided by area of BDE. This we are doing. So we need to prove the ratio of these triangles are same. Now we know area of AD is of AD into EN, and area of BD equal to half dB into EN. Okay. Now we can strike out EN, and then half and half also can be striked off. Now what is left is AD by dB. Now similarly, we are writing the triangles formed on this line. These are area of triangles formed by that line. These are area of ADE by area of DEC. That means AD, this triangle A, this triangle, and DEC, this triangle, because both are formed on this line. Okay, so their ratio should be same. Now, so again, let's expand that. What was it? As per what was written above, area of ADE equal to area of half into AE into DM, and area of DEC equal to half EC into DM. Again, both of them can be striked off. These can be striked off. So what is left now? What is left now? AE divided by EC. Now we need to note one point here. Angle BDE, sorry, triangle BDE triangle BDE, this triangle BDE, this triangle, and triangle DEC, this triangle BDE and DEC are the same base. of DE, same base as DE. So this triangle has the base DE and this triangle also has the base DE, and this is also between the same parallels. BC is parallel and DE is parallel. So these two triangles are between these two bases. So now with this one we can write AR, area of BDE, equal to area of DEC. So the area of BDE and the area of DEC will be same, because they are based on DE and they are between the uh, parallel lines DE and BC. I had to mark this 1, 2 and 3. Therefore, from the theorems, from the points 1 to 3, AD by DB equal to AE by EC. So let's understand why this is. Because, so if you see the point 1, area of ADE, area of BDC, okay, equal to AD by BC, and area of ADE equal to area of DEC, and is the second one, okay, which is AE equal to BC. Now since we are saying from the note area of BDC equal to area of DEC, then we can replace area of DEC with area of BDC. If you replace area of BDC with DEC, then both will become area of ADE, area of BDC. This is also area of ADE by area of BDC. So now both have become same. So then AD by DB and AE by EC also become equal. That is the logic.